What's up, mathematicians? Welcome back to lesson 6 in our unit on measurement. This lesson is all about applications of right triangle trigonometry. Now, in this video, I'd like to share with you an application from my own life experience, and that is with woodworking. So I recently built this play structure, here you can see, for my daughter. And as you might be able to guess by looking at it, something like this involves a lot of measurement and also involves a fair amount of trigonometry. And so I want to share with you a couple examples where trigonometry was involved in the design, the planning, and also the calculations to cut the wood for this particular project. So the first one that I want to share with you is this right here. So in order to make the structure stable so it wouldn't wobble back and forth, I wanted to put these cross beams in here. Now, because it's easiest and quickest with my miter saw to cut at a 45-degree angle, I decided to make these cross beams. I decided in the arrangement so that the width between the two beams, between the two posts, I guess, would be the same as the height. So basically, these cross beams are inside a square. So let's look at how we could use trigonometry to figure out how long those cross beams should be when I cut them. Okay, so here's my setup, and these are the posts, and here are the support braces. The distance, the inside distance between these two posts right here is 32 inches in my design. And as I said already, because of how easy it is to cut the 45-degree angles with a miter saw, I decided to make this basically a square. So since this is 32 inches, this distance will also be 32 inches. And so the question is, how long should I cut each of these support beams? And in order to figure this out, now in the next lesson, I'm going to teach you another tool that you could also use to figure this out, but we're going to solve it using these tools for right triangle trigonometry that we've learned. So let's go ahead and recognize that we have a right triangle here, and I'll draw in the side right here. Okay, so we know that this is a right angle. We'll assume that I've set up my posts so they are perpendicular to the ground. I've done a good job with that. And so I know that this length is 32, this length is 32. I want to find this length right here. But the fact is I'm not sure about this angle. However, this angle won't be too hard to find because I can see from the setup that the rise is equal to the run. So let's think about that. If the rise and the run are equal, 32 divided by 32 is of course equal to 1. And so that means that the tangent of the angle, I'll put theta in here, this is the angle that I need to find first. The tangent of theta is equal to 1, since the rise and run are equal. Let's go ahead and look that up in our table. Okay, so according to this table, I go to the tangent column, and I will go all the way down until I can see the tangent of exactly 1. That comes when the angle is 45 degrees. So that means that this angle right here is a 45-degree angle. Okay, so now I want to find the value of x. And in order to do that, I can use either the sine or the cosine because I know the rise and I know the run. So let's go ahead and use the sine. I'm going to go ahead and say the sine of my angle, which I now know is 45 degrees, is equal to, well, it's going to be the opposite, the rise, which is 32, divided by the hypotenuse, which is x. Of course, you could also do the approach that I talked about in the previous lesson, where you divide everything through by the hypotenuse. And if you did that, you would divide everything by x, and you would get 32 over x, which is exactly what we see here. So either way, it's going to be sine 45 equals 32 over x. Now, to solve this for x, I'll multiply both sides by x. These cross out, and I get x times the sine of 45 degrees is equal to 32. And now I divide both sides by the sine of 45 degrees. Well, these cancel out, and I get that x is equal to 32 divided by the sine of 45. Let's go ahead and look up what the sine of 45 degrees is in my table. Okay, so 0.707 according to this, which incidentally is the same as the cosine of 45 degrees. At a 45-degree angle, the sine and the cosine are equal, and that makes sense, right? Because the tangent is just the sine divided by the cosine. So if they're equal, we're going to get a tangent of 1. So let's go ahead and write this out. So 32 divided by 0.707. Now I'm going to plug that into my calculator. So I'll type in 32 divided by 0.707, and I get 45.26. All right, 45.26. Now, because I'm working with sort of the English system, this is in inches, and when you use, let's see, do I have it? Yeah, so here's a ruler. You can see that when you're using the English system, the units are not broken up the same way as they are in the metric. And so we see the inches are broken down to halves, and then quarters, and then eighths, and then sixteenths. So this 45.26, that's really close to 45 and a quarter. So since I'm using this side of my measuring tape, I'm not doing this project in metric, just because typically when we're doing, I don't know, woodworking and construction jobs in the US, people use the English system, and all the stuff I'm buying at Home Depot and the drill bits I have is all based on this English system. So I'm going to go ahead and convert this, or not convert it, but I'm going to round sort of to the nearest eighth or 16th of an inch, which is 45 and a quarter inches. So that right there is the length that I would cut this cross beam to, the support brace to, 45 and a quarter inches. Okay, so now I want to show you one more calculation that I did using trigonometry for this project. You see the A-frame there on the right side, on the other side of the swings, and I want to show you how I did the computations to figure out the length to cut those boards, those braces, for the A-frame. Okay, so because this whole A-frame is tilted, this calculation needs to be done in 2 stages. First, I need to find the height of the A-frame, and then after finding, so this right here, this is the height of the whole A-frame. Then once I find that height, that's going to be this height right here, I'll need to find the actual length of those boards. I can go back to the picture here. I'm not sure if it's clear from the picture, but that A-frame there is not perpendicular to the ground. It is tilted at a 15-degree angle away from the swing set. So let's do this 2-stage calculation. So first off, we're going to find the height of the A-frame. And so this right here is a 15-degree angle. It's tilted at a 15-degree angle. And the height of the swing, like the plank where this I don't know, beam where the swings are attached to, the top of that is 92 inches from the ground. So I'll write in here 92 inches. So that's this height right here. Now this is a right triangle, and the thing that I want to find out is this right here, the height of the A-frame. Okay, so let's go ahead and take the approach where we'll just divide everything by the hypotenuse and turn this into a unit right triangle which, the actual right triangle outside is similar to. So let's see, divide everything by x. So I get 92 over x, and of course this right here is equal to 1. So then this 92 over x, is this the rise or is this the run? Am I using sine or cosine here? Well, if you're not sure, you can always turn your paper sideways to put the 15-degree angle, sort of at this orientation. And so the inclination is above level. When you turn it like this, it's clear that this is the rise and this is the run. So since this is the run, we're going to be using the cosine. So let's set that up. We're going to go ahead and say that the cosine of 15 degrees, I do know the angle, is equal to 92 over x. Now, in order to solve for x, of course, I multiply both sides by x. These cancel out, and I have x times the cosine of 15 degrees is equal to 92. Now, I'll divide both sides by the cosine of 15 degrees. Cosine 15 degrees. Those cancel out. And I'll go ahead and just plug this one in my calculator. I encourage you to try both, using a table sometimes, using a calculator sometimes, and sort of get to know which one you prefer, which one makes the most sense to you. And so that's why I sometimes go back and forth between the two. So you can see that both works, and it's just a matter of preference. Typically, the calculator ends up being the faster way when you get used to it. So we'll type in 92 divided by the cosine 15 degrees, and I get 95.24. I'm going to round this, in fact, 95.245. So if I round this off to the nearest hundredth, it actually does give me 95.25. So I'll round that off, and that gives me to 1/4 of an inch, which is an easy measurement with the measuring tape that I'm using. So we get 95.25 inches. Okay, so again, this is not the number I'm looking for. It's a stepping stone to the number I'm looking for, because now I know the height of the A-frame, but I do not know the length that I need to cut the boards to. So let's go ahead and write that in here. Let me write it sideways. So 95.25 inches. And these angles right here are both 15-degree angles right there. And of course, these are both right triangles. So I can use either of these two right triangles to find this slant height. We'll go ahead and call it x. Keep in mind that this x is not the same as this x, right? These are sort of two separate problems, even though they're both, things that we need to do to solve the ultimate problem of this slant height here. Okay, so now let's take the other approach, where we just write down the sine, the cosine, or sorry, the opposite, the adjacent, and the hypotenuse. So the opposite, from the perspective of my 15-degree angle, the opposite, I don't know what it is, and I don't really care because I want to know this length. The adjacent is this side right here, so 95.25. Ooh, I'm not going to have space to write that, so 95.25. Okay, so sorry, it's a bit small there, but that's this number right here. And finally, the hypotenuse is equal to this length here, x. Okay, so I'm not going to use the opposite. I'm going to be using the adjacent and the hypotenuse. Therefore, I will be using the cosine ratio once again, which is what I used here. So let's set this up. The cosine, once again, of 15 degrees, because I decided to set it up as 15 degrees, from vertical on both sides, meaning this is a total of 30 degrees. So the cosine of 15 degrees is equal to the adjacent, which is 95.25. Oops. Let me rewrite that. Sorry about that. cosine of 15 degrees is equal to the adjacent 95.25 divided by the hypotenuse, which is x. Now, once again, I'll solve this. I'll go through this fairly quickly because I've done it a few times already. All right, divide both sides by cosine of 15. And let's go ahead and just plug that in the calculator straight away. So we have 95.25. Oops. Let's plug in the calculator correctly. 95.25 divided by the cosine of 15 degrees, and I get 98.61. Okay, so if I'm, basing this on the English system where my measuring tape has halves, quarters, eighths, sixteenths, this is going to be pretty close to 98 and 5/8. So I'm just going to go ahead and say I'm going to cut those boards to 98 and 5/8 inches. So what does this mean? Well, when I go to Home Depot to buy boards, they sell them in 96-inch lengths. That's 8 feet long. And then the next one up might be 10 footers, 120 inches. Although for this particular application, I was able to find one a little bit in between. I think I found a board that was like, I forget, like 104 inches or something like that at Home Depot. So I knew that I needed boards that were longer than 8 feet. And so I found the shortest boards I could find longer than 98 and 5/8 inches, because I knew that was the length that I needed to cut them to. Okay, so that wraps up this particular video. As always, thank you so much for watching. In the next video, we will be looking at how we can use right triangle trigonometry to measure the distance across a river. And yeah, so join us then. And until then, bye-bye.